All right. All right, looks like we can go ahead and get started. Thanks everybody for coming today to our 2022 Inorganic Ventures webinar series. My name is James King. I'll be introducing our speaker today as well as moderating the questions. And today we'll have Ashley Jones, one of our technical support chemists, talking about custom CRMs and making them in your lab. Ashley is a chemist with experience in CRM manufacturing, product design, customer support, and occupational lab safety. Today, she is a technical support chemist, and she also acts as our lab safety officer for Inorganic Ventures. Ashley is a Blacksburg, Virginia native and graduated from Virginia Commonwealth University with a bachelor's in biology and a minor in chemistry. Without further ado, I'm going to turn you over to the more than capable hands of Ashley Jones. Ashley?
Hello, my name is Ashley Jones, and I'm a technical support chemist here at Inorganic Ventures. Welcome to today's discussion of custom certified reference materials. Today we're going to go over a little bit of an overview of how we make these products, as well as some of the benefits to purchasing custom certified reference materials as opposed to making DIY solutions in your lab. So for an introduction into IV's products, first and foremost, we are ISO accredited and registered with 17034, 17025, and 9001. These are how we make our products, how we test our products, and how we run our business, how we sell our products. We are also NIST traceable. Now, many folks are familiar with NIST SRMs and their purpose in a certified reference material manufacturing setting. We don't stop with SRMs, so our balances are also calibrated with weights that are traceable to master weights, and our balances are calibrated by accredited calibration labs. We also use NIST traceable thermometers in our lab, which again are calibrated by accredited calibration labs. We also have a standardized in-house procedure for calibrating our flasks, both glass and plastic, to ensure that we are mitigating and recording any uncertainties that could be involved in our dilution process, because these uncertainties are wrapped into the uncertainty of our final certified value. So we want to make sure that our process is as reliable and as traceable as possible. We have over 63,000 unique approved solutions available for order. We create 10 to 14 new solutions daily. So if there's something that you need that you haven't seen before or that you're unable to find on our website, we can certainly make it for you. So how do we make our products? How did we get 63,000 solutions into our database? Step one is going to be new product development by technical support chemists like myself. This is a two-step PhD reviewed process where we will look at compatibility and long-term stability, as well as any manufacturing, testing, or paperwork conditions that need to be noted up front. Before we can manufacture the products, we need something to manufacture them from. This is in part the responsibility of our bulk manufacturing technician, who will take our purity tested starting materials, go through the necessary reactions to get these into high concentration aqueous solutions that we can then aliquot from down the line. Once these solutions are made, they are handed over to our quality control department for verification of the certified values so that we know with certainty what we're using to create your products down the line is reliable and consistent. So once we have our approved solutions and our certified in-house concentrates, when a product is ordered, that order will then go to our manufacturing department for production. Now this is done through a gravimetric preparation, which we will get into in a little bit more detail later on. And this preparation is driven by our audited work instructions under our scope of accreditation. So these work instructions help us to maintain consistency across all of our products and across all of the lots of the same product. So if you order a product 15 times, we want it to look as identical as possible all 15 times. So we take these work instructions and we create manufacturing breakdowns, which work sort of like a recipe for our products so that our technicians can make that product the same way each and every time. So the general procedure for manufacturing our products is that the technicians in manufacturing will obtain their breakdowns for the solutions ordered. They will then go and collect those certified in-house concentrates that our bulk technician made previously. Those technicians will then verify the correct product, the concentration, the lot number, and the density to make sure that they have the correct product to aliquot from, as well as to make sure that they're using the most applicable certified concentrate for that aliquot size. So aliquots are then weighed out according to the final concentration desired in the product. Once all aliquots have been weighed out and added to the solution, that solution is then going to be diluted to final volume and mixed 50 times by inversion before a retain is taken for our quality control department to test, and the remainder of the product is sent over to be bottled. So once the retains are handed over to quality control, they will then test our products to verify the certified values that are calculated from our gravimetric manufacturing process. Once those certified values are completed through their testing process, all that information will be handed over to our product documentation department for generation of our certificate of analysis. Now, the certificates are going to include more than just the certified values. You're going to have the applicable ISO information at the top. You're also going to have the product description, which will include things like your catalog number, your lot number, the matrix, your analytes, things of that nature. We'll also have, of course, the certified value and information on the assays used to verify those certified values. This is going to also include our NIST traceability information, partly in our assay information with any SRM lots that may have been used, as well as just some general information about our NIST traceability as a company. There will also be trace metallic impurity information if that is applicable. And then there will be some additional information on storage and handling and things of that nature. If you want to obtain your certificate of analysis or your SDS for a product that you may have already, you can scan the QR code here on the screen, and this will take you to our C of A and SDS search on our website. There you will enter the product name, so the product code, catalog number, and then the lot number, and that will allow you to search any available paperwork that we have on that product. So you've heard me talk a lot about gravimetric preparation and how this is our preferred method for creating our products here at Inorganic Ventures. There's a reason for this. Generally speaking, this is more reliable and consistent than volumetric preparation. You're going to avoid things like some of the pitfalls of plastic consumables, like adhesion. There are some elements that are more sticky than others. They're going to want to adhere to that porous plastic surface. Weighing out your aliquot and then transferring quantitatively allows you to avoid some of those issues. There's also going to be an increased accuracy. So again, first and foremost, temperature and pressure are directly related to the volume of an aqueous solution. So as those variables change, so will your volume. So weighing your aliquots out will help to mitigate some of those side effects that you'll get from that. We're also going to be able to maintain a smaller margin of error, so our aliquots here are measured out down to 4 decimal places for anything below 30 grams and down to 2 decimal places for anything above 30 grams. This helps us to, again, mitigate and reduce as much uncertainty as possible. You're also going to have issues with viscosity. If you're weighing out a very thick, viscous aqueous solution, it's easier to quantitatively transfer that by weight as opposed to measuring that out volumetrically and trying to make sure that you maintain all of that aliquot as you transfer. You also have the ability to adjust aliquots if you're weighing things out in a secondary container, such as a disposable plastic weigh boat. We can make sure that our aliquots are very, very accurate because we're able to add and subtract solution as necessary. It's also just going to reduce some of our costs. So transfer pipettes and weigh boats are a little bit less expensive than things like pipette tips. We also don't have to rely on the calibration of our pipettes. If we have pipettes that need to go out for calibration, we don't have to stop our manufacturing process. It's also a lot more accessible to use transfer pipettes and weigh boats. We can have many more manufacturing technicians working at a time as opposed to having to equip all of these manufacturing technicians with the more expensive volumetric pipetters. So to demonstrate some of the pitfalls of the accuracy of volumetric aliquots, let's walk through our preparation. So if we wanted to make a 100 milliliter solution of 1000 ppm calcium, our calcium concentrate has a concentration of 119,910 parts per million and a density of 1.341 grams per mil. So in order to calculate the volumetric aliquot, we're going to multiply the volume of the total solution, 100 mils, times our desired concentration, 1000 ppm, divided by the concentration of our concentrate. That'll give us a volumetric aliquot of 0.83396 milliliters. In order to get the gravimetric aliquot, we're then going to multiply that number by the density of our concentrate to get 1.1183 grams. So our volumetric aliquot is 0.8340 and our gravimetric aliquot is 1.1183. So in order to measure out this aliquot volumetrically, I'm going to take my 1 milliliter pipetter and set it to 834 microliters. I'm then going to aspirate from my concentrate bottle, and just to show you what this ends up weighing, I'm going to transfer this over to an aliquot on our 4-place balance. This gives me a final weight of 1.1107 grams. As opposed to our 1.1183 grams, this is a 0.68% variation. Now, this isn't catastrophic, it's not ideal, but the issue here is that our 1 mil pipetter is not calibrated and might not be as accessible to all labs. So if I go to our next size up, which is our calibrated 10 milliliter pipetter, and I set it to 0.83 milliliters because that's as far as I can go into my significant figures. I do the same process. I aspirate from my concentrate bottle and transfer to my 4-place balance. This is going to give us a final weight of 1.0744 grams compared to our theoretical aliquot, which should be 1.1183 grams. This is nearly a 4% variation, which is obviously not acceptable and is not going to give us the results that we want. If we did this gravimetrically instead of volumetrically, we can make sure that our aliquot is exactly 1.1183 by adding our aliquot to the weighboat and then adding and subtracting solution as necessary to meet that theoretical aliquot as close as possible. So at the bottom of this screen, you'll see a QR code. If you scan that, that'll take you to our online quote request form where you can submit a request for an existing solution that you have ordered already. You can request a revision to an existing solution. If there's something you would like to tweak, we can do that for you. You can also request a product from another manufacturer. So if that product's no longer available, or maybe you would just like to source all of your products from the same manufacturer, you can insert your product information there and we will create an analog for you. And then of course you can also request a brand new custom solution that is tailor-made to your needs. So you can enter your elements and desired concentrations and we will create that perfect fit solution for you. But what if you're already doing gravimetric preparation in-house? Or what if you have a calibrated 1 milliliter pipetter and 0.68% variation is just not something that you're worried about? What is the benefit to buying a product from Inorganic Ventures? One of the most important things on every lab's mind is reliability. We're going to have traceable results and therefore so are you. We have that unbroken chain of comparison to NIST, and by using a NIST traceable product, you're going to have traceable results. There's also our documentation associated with CRMs. We talked about our certificate of analysis previously. If you find yourself in an audit, you can go on our website and pull the SDS and the certificate of analysis for any product at hand, and those are going to contain all the information and then some to keep your auditors happy. You're going to be able to reduce some of the interferences that may be associated with stock multi-element blends. Maybe there's a stock solution that is pretty close but has a couple extra elements that might be problematic for your method. By creating a custom multi-element blend, we can make sure that that product that you're using is exactly what you need, nothing more and nothing less. We also have a pretty great uncertainty. Our typical uncertainty is 0.5%. And then we have those ISO accreditations / registrations. So you know that your products are being produced under an audited and consistent process, and that your products therefore are going to be consistent. You're going to save a lot of time and money. You're going to reduce waste in the number of solutions you need to purchase. Instead of buying 23 single element solutions to create your own MEB in-house, you can buy one 23 element solution. Then you don't have to go through the process. This is going to save you a lot of working solution prep time. You don't have to create that solution. You don't have to aliquot in 23 elements. All you have to do is dilute that one MEB and move on with your method. This is also going to avoid the need for in-house stability and self-assigned usage periods. If you're creating your own working solutions in-house, you're going to need to know how stable that is and for how long. By purchasing these solutions through IV, we've done that work for you, and you know that our products are going to be stable because we design them to be as stable as possible for as long as possible. And this takes us into our Transpiration Control Technology. One of the biggest benefits to Inorganic Ventures products is our Transpiration Control Technology. But what is transpiration? Why is it a concern? And why do we need to control it? Anytime you have an aqueous solution in a vessel, the water molecules in that solution are going to want to move to a less concentrated environment. Even though the bottle is sealed, there's a heat shrink wrap to help us prevent leakage and transport, the water molecules are still going to want to transpire through the walls and neck of the bottle. This is a problem because as more water leaves your solution over time, the product left behind in the bottle is going to become more and more concentrated, and you will eventually reach a point where the actual concentration no longer matches your certified value. By putting a TCT bag around our products, we're able to create a microenvironment where equilibrium is met much sooner, and therefore much less transpiration can and will occur. Once you remove our product from the TCT bag, there's a 1-year usage period from the date that you remove it until that product is considered expired. This is due to our transpiration effects. While that product is still in the sealed TCT bag, the product is considered reliable and usable for 5 years from the date of manufacture. This gives you a lot more control over your method. You can buy a larger volume in a series of smaller bottles. This will help you maximize on our multi-bottle discount pricing, and will also give you a lot more control over your product. So if you need 500 milliliters total, you could buy 4 125 ml bottles. This will allow you to maintain your lot number for longer, so all 4 of those bottles would have the same lot number. You can also reduce contamination potential because you're only using 1/4 of that product at a time, one 125 ml bottle. That way, if that one bottle becomes contaminated, you don't have to worry about the entirety of your lot being contaminated. And this also allows you to control the expiration of your inventory. While you're using that 1/4 of your product, the other 3/4 are still safely in their TCT bags on that 5-year clock, as opposed to that 1-year expiration. If you scan the QR code here at the bottom of the page, that'll take you to our TCT education page, where you'll find more information about the studies we did related to transpiration, frequently asked questions, and things of that nature. So just as an aside, one of the more common questions we get about transpiration is whether TCT is the only way to slow or to mitigate transpiration. And the short answer to that is no. Refrigerated storage can also be used to reduce the effects of transpiration. We do recommend that you allow the standard to come to room temperature naturally and then mix by inversion 50 times before use to ensure that you have a homogeneous solution going into your method. Our certificate of analysis does contain storage and handling information in section 7. Here you'll find the optimal or recommended range of temperature for storage while in the TCT bag, as well as an overview of some of the information that we discussed on the last slide about the effects of transpiration on your products, and then the optimal storage and usage temperatures once that bottle has been removed from the TCT bag to help to mitigate some of those volumetric dilution errors that we discussed before. We have a really great education page on our Inorganic Ventures website. If you scan this QR code, it will take you there. This is where you can find things like our interactive periodic table, our sample preparation guides, our technical forums, other research papers, blog posts, and things of that nature that we have produced. This is a really great jumping off point and a really great collaborative space to find ideas and information, frequently asked questions, and we highly recommend that you check it out. We certainly use it internally every day. Before we move into questions, I just want to take a moment to thank you all for your time and attention here today. I've enjoyed discussing our products that I am so proud to represent, and I hope that you've learned something new about our company and our products. We'll be more than happy to answer any further questions that you have. Thank you again for your time, and we look forward to working with you soon.
All right. Thank you, Ashley. We appreciate you discussing that with us this morning. So with that, we're going to move into the question and answer session. So if anybody has any questions, please make sure you post them down in the Q&A section in the Zoom apparatus. We're going to get started with one here. So Ashley, can you talk about some elements that don't play well together, and particularly if you've gotten comments or concerns or questions from customers in your role with technical support? What kind of what elements are people having issues with or seeing problems with?
The most common problem that we're going to see is going to be with HF and HF sensitive elements. That's usually what is going to cause a solution to need to be split. This is because we have some elements that need HF for stability. We have some elements that are destabilized by HF. We have some elements that destabilize HF elements. So we're going to have to keep an eye on the concentrations of those elements together to make sure that they're not getting to a point where they're no longer going to be long-term stable. We do this where we split solutions and stuff so that your product, like I said in the presentation, will be as stable as possible for as long as possible. So we could potentially keep these things together, but it's not going to be stable for as long. So if we split it, then we can make sure that you have that 5-year usage period and you can combine those in your working solution and not really have to worry about those kinds of things. But HF elements definitely are the biggest contender that we have when we're quoting new solutions.
Okay. All right, thanks for that. So I've got another one here. Is there a limit to what we can have in a CRM as far as elements, concentrations? Do you have any feedback on that?
Yeah, so concentration and then like matrix effects are going to be the biggest things that we're looking at as far as your limiting factors for what can be in a CRM. So once you start getting into like that 10,000 ppm range, we're going to have a lot of issues with being over volume with our aliquots. We'll see that your total aliquot volume will be like 200% total volume. And obviously that's not going to fit. We'll also have more compatibility issues the higher our concentrations get for things like HF elements. You know, we can go up to around 100 ppm with trace HF for those sensitive elements, and that's kind of our limit. So compatibility and volume, things like that are definitely going to be our limiting factors for what can be in a CRM. We do have lower limits as well. So you can find our scope on the website where you can see how low effectively we are able to go under our scope for things in a CRM. So if you're around 10 ppm, we can get just about everything in there. Once you start getting really high or really, really low, that's when we're going to have some more complications.
Fair enough. Okay. All right, thanks for that. It looks like we have a question from an anonymous attendee. When blending standards, what density value would I use to work out the final weight of the solution?
The final weight of your...
I believe they're asking about like when they the final weight of the working solution that they're trying to make.
I believe that will depend on what is in your working solution. Correct me if I'm wrong, James.
Yeah, so typically, I mean, if you're not doing it by volume, if you're doing it by weight, yeah, Ashley, correct me if I'm wrong, you can actually kind of negate the density by doing them by weight, right?
Yeah, when we do gravimetric preparation, the density sort of comes after we get our final weight. We'll add all of our aliquots, and then we dilute by weight to that final volume, and then we kind of get the density from there. And then again, that's going to depend on, your density is going to be affected by what is in the solution and how much.
Okay. Good. All right. So we have a question, and please forgive me if I say anybody's name wrong, but from Movin, what is your limit for trace HF?
So trace HF, for our purposes, we consider trace to be anything equal or less than 0.3% volume per volume HF. So are you asking what trace HF is, or what our limit is for elements?
Look, yeah, they just said what is your limit? So we can, about 0.3. Once we get to about 0.3, that's when we report the actual volume.
Yeah, our HF sensitive elements, so like the group 2A elements that are going to be sensitive to HF, we can do up to about 100 parts per million before we start to have issues with that. With things like rare earth elements, we're gonna try to avoid HF as much as possible. So 0.3% is what trace HF is, and up to about 100 ppm for most of our sensitives.
Sure. Okay. So this next question is from Gavin. Online, you offer a 10 ppm mercury standard in nitric acid in glass or a glass bottle. You also have a 10 ppm mercury in HCl in a plastic bottle. If I'm using this in a multi-element standard that includes boron and sodium, but the diluent has nitric acid, which is the better standard to use?
If you're going to be analyzing, boron and silicon is usually the bigger concern. That is where you're going to want to go with HCl, I would say. The reason that we put the mercury in nitric in glass is because it's going to stick to the plastic bottle. The HCl will help us not do that. So I guess it depends on what else you are analyzing.
Yeah, I would just add that if your method includes boron and sodium, you're probably going to in your diluting in nitric, if at all possible, you may want to try to do some sort of a mix with HCl to keep mercury a little more stable. The carryover may, but I don't know what other elements they have. Like if you have silver or thallium or something, you could have some issues if you bring over chloride from the chloride mercury standard. But you generally want to stay away from that 10 ppm nitric one in the glass, because glass is typically pretty dirty. It has things like boron and silicon and things like that. So
yeah.
Okay. Sweet. Moving on. This one's from Chris. If IV are unable to make my desired blend, would they suggest the best matrix split, etc.? So I guess kind of talk about your process, particularly you guys, since you're in technical support and you all deal with this. What is your process for when we're unable to answer or provide a custom as requested?
Yeah, so if you request a custom solution that is going to have some kind of compatibility, stability issue, we're going to take a look at the best way to get your requested solution. If it needs to be split, we want to split it as little as absolutely possible. So if we're able to change the matrix to avoid some of those issues, we will do that. If a split is necessary, again, we will try to split as few elements as possible. We try to keep it pretty simple for your method. So we would definitely suggest or go ahead and quote in the best alternative. And then if we get feedback that our suggestion doesn't work, or the matrix that we used would cause issues or things like that, we can definitely reevaluate and work together to build a solution that will be the most useful and the most stable.
Cool. Fair enough. Thank you for that. Okay. And thanks for that, Chris. So our next question here is from Robert. For your CRMs, can you indicate whether the solution is appropriate for use as a stock solution or for further dilution?
Yeah, so if I understand your question correctly, that's sort of what a lot of our customers do with these custom multi-element blends. If they need to do, say, a calibration curve and they're going to do a serial dilution, they'll buy a 100 ppm standard with their elements in it, for example, and then they can take that solution and do their dilution from there. So it is sort of used as a stock solution. I think there has been some confusion that we've seen recently, sort of a misnomer between stock solution and our stock products. Our stock products, they're going to be manufactured on a much larger scale so that we're able to produce more product with that same testing. And that will be a lot cheaper for the customer on that end because we're able to do one batch of that product and have a lot of product, and that cuts down our costs and things. So that translates to you. But a stock solution for dilution, I think is what a lot of people tend to use our MEBs for.
Makes sense. Okay. All right. Thanks for that. All right. Next one is from Gavin. If using gravimetric prep, can you just use the mass to mass ratio as ppm or ppb instead of converting to concentration in order to avoid using specific gravity? That's a good one.
We do. Some of our products are weight to weight is what we call them. So we can sort of avoid that, like you said. So yeah, you can. That is definitely an option to do mass to mass for your solutions.
Okay. Fair enough. All right. This next one's from Matt's. Curious if you have any experience using amber glass for standards, thinking of light sensitive elements.
Yeah, so we do have some amber glass bottles. I think they're more expensive and they're a little bit harder to get your hands on. So while we have them, yeah, true story, they're a lot less clean. So for our light sensitive elements, when we manufacture them, if there's a blend that we know is going to be light sensitive, we make sure that that's labeled before we manufacture it so that we can keep that in mind. Once those light sensitive elements are added, we make sure to add those last. We'll then just go ahead and cover that solution until it is bottled, and then we put it immediately in that TCT bag to keep it out of light and things like that. So that would be an option, but there are benefits to just covering it and keeping it from light exposure.
Yeah, cleanliness is one of our top priorities. I mean, it makes sense because of the nature of the business we're in. So, okay, cool. Excuse me. All right. Our next question comes from Scott. How does my matrix relate to your CRM matrix? I am using 5% HCl, 5% nitric. Will that make a difference in the blend? It's a good one.
So if you're requesting a custom solution, you can request a matrix. So if there's a matrix that you're using in-house for your method, you can request that we use that matrix. And as long as that is compatible with the stability of the solution, we should be able to do that and wouldn't really cause any issues unless, for this one, 5% HCl and nitric, we're going to look at hydrochloric in presence of things like silver. So if there's a matrix that you want, we can definitely work with you to get a CRM in that matrix.
Yeah, I just add that most of our CRMs, they come in either nitric or HCl, and typically if you're diluting, you're diluting your working solutions down to those 5% of each of those. it typically shouldn't be an issue unless you're doing really, I guess it would be small dilutions with high acid coming from our solutions that might mess up the matrix matching, but otherwise it should be fine. Okay. All right. We're kind of moving towards the end of these questions here. So another one from Movin. Are all of your custom CRMs, or excuse me, hold on, let me start all over. Are all of your customs certified reference materials, or do you have some that are just reference materials like speciated standards?
We do have some that are just reference materials, correct, James? Most
Yes,
of our products are going to be certified reference materials, but we do have a few that are reference materials.
Yeah, I believe our speciated standards are CRMs, but some of our things like I'm trying to think of any that come to mind off the top of my head. The matrix modifiers, I believe, come to mind because they're not, some of those the class of those aren't technically certified because you're not using those specifically to compare against something. You're using them to manipulate an environment.
Yeah, our atomic absorption standards as well, I believe.
Some of it's semantic. I think those still fall into the CRM, but I see what you're saying though. But yeah, we have a select few reference materials, and you could just contact us directly if you have any questions on those. Right. Okay, it looks like we've got our last one here. Do you have primary standard and secondary standards apart from NIST standard? So basically, what I believe Pintu is asking is, do we have maybe backup primary standards apart from NIST?
I believe so, but I'm not 100% sure.
So just to hop in, I don't think, if they're asking if we have another NMI, another National Metrological Institute that we purchase from, at the moment,
yeah.
I don't believe we do. I believe we only get things through NIST. I know we're working on a project for possibly developing some primary standards, but to my knowledge, I don't know that purchasing is going through any other NMI right now. So
yeah, I don't know if that would apply to anything that we use in-house to compare. Yeah. But not a national.
Sure. Okay. It looks like we have, we're going to go ahead and probably cut it off with this last one. Everybody's been asking a lot of great questions, so we definitely appreciate that. But our last one comes from Movin. What is the difference between your AA and OES standards?
I want to say there really isn't much of one. The AA standards are very similar to our CG, the custom grade standards. It's just a level of testing and paperwork that comes with it. Our AA standards are sort of, they're effectively the same, but they're sort of a cheaper option because they come with less of that rigmarole through testing.
Carry the guide. So, they don't carry the guide 30, ISO 17034 standard because the testing isn't as stringent on them.
Yeah, so those are often used for just sort of informal in-house checks for other labs and stuff, but they're effectively the same.
Cool. Okay. All right. Well, I'm going to go ahead and close this off here. So thank you everybody for coming. We appreciate you guys' participation. Thank you for coming and listening to Ashley talk about standards, and thank you for all of your questions. And we hope to see you at the next one. So thank you.
Thank you.